Welcome to this training course. Today we're going to talk a bit about components. In a previous chapter we saw how to add components from the library into your models. Today we're going to talk a bit about some specific commands to help you create components on the fly, things like windows and stairs. Okay, let's open BricsCAD BIM to see what this looks like. Okay, so on this building here we have a couple of lines and polylines drawn on the facade. We can use these lines and polylines to create a window on the fly without needing to find a library component that fits this exact shape. You can find the BIMWINDOWCREATE tool under the Modeling tab in the ribbon, Create Window. And it asks us for a profile, which is a boundary, a closed polyline, or a grid. In this case, I will use this closed polyline, a rectangle. Once I select it and press enter, I'm presented with some window styles. For example, a window with 3 parts vertically. So I can choose this and automatically it will be created for me in this shape. If I select the window, I can open its properties panel and I'll find that actually the window is entirely parametric. So I can still change the width and the height. I can change the offsets for the millions. So for example, if I don't want it to be equally spaced, I can enter some different values. Okay, let's undo these few steps and show you another way of creating a window using this command create window. And that's by using a boundary. So first of all, I will enable my boundary detection selection mode, which means that if I now hover my cursor over a closed boundary on a face or on the current XY plane in the UCS, I will see that the boundary is being highlighted in green. I can use this boundary again as a shape for my window create tool. So I could select 2 separate boundaries like this and then use the create window command. Let's just choose this simple style here. And I will now have 2 separate windows with these specific shapes. Again, I can change the properties or the parameters like lining thickness, placement depth, and so on. Finally, create window also works on grids. Okay, let's create a grid on this facade here. And let's choose cell width of 1.2 meters, cell height of 2.3 meters. And let's create a grid of in total 12 meters long, like this. I will move the grid a bit so it's more central in the wall face. Like this. And now I can use this grid as a basis for a new window using the create window command. Select the grid. And there we have our new window based on this grid. Again, it's parametric, so I can change a few properties like the frame depth, glazing depth, and so on. So those are some ways of creating windows on the fly using shapes in your model like lines, polylines, grids, and so on. If I want to, I can also make changes to my grid. So for example, before creating the grid, I can block edit this grid and let's say make a change like this. So that one of the two of the grid cells are actually not rectangles anymore. And still the create window command will work and it will create a window with this one odd shape here in the middle. And you can go as far as you want in that. We have an example here of a grid that was so manipulated you don't see even the rectangles anymore. Every axis is rotated. I can use this to create a window like this quite easily. And again, I can change my, let's say, my frame depth. Now, for the sake of copying this window over to the rest of my model, I will not do a manual copy. I will actually use a smart tool called Propagate. So we'll see in a later lesson what Propagate can be used for, but for now I will propagate the window in this wall, choosing the window as my reference solid, the wall as my reference solid, the window as a detail object. And Propagate will search for a similar location where I can apply this window. So I can choose, for instance, like this. Turn off some suggestions. Like so. And just like this, we've copied this window over a couple of times to the rest of the building. Next to the window create tool, there's also a curtain wall tool, which can be used for more advanced shapes and glazing objects. So for that, I will open this drawing, this curtain wall drawing here, and show you two simple examples of how to use the curtain wall tool. First of all, let's use a simple example, this one here. Now let's say we want to turn this entire wall, or this entire solid here, into a glazing object. So I can use the curtain wall command for this, and it asks me to choose a face, a 3D face of a solid, to create this curtain wall. Automatically it divides this face into cells of equal width and height, which I can then of course still change. So I can say maybe this should be 1 meter wide, or let's say 1.5 meters, and then maybe let's say 4 meters high, give or take, and it will choose a value that's close to the value we entered, so it fits the actual selected face. Alright, after pressing enter, I'm presented with some options like changing some more parameters. For example, the width and the depth I can still change. That means the width and the depth of the actual transoms and mullions. So let's choose a depth of, let's say, 200 mil, and press enter to accept. It will then create this curtain wall with my mullion and transom thickness of 200 mil. And it will create this as a block entity, a block reference. Note that we cannot change the parameters anymore after using the curtain wall tool. So that's one big difference between the create window command and the curtain wall command. Once you've created it, there's no way to edit the parameters that make up the object anymore. So you have to do it up front. Alright, I could now repeat the same step over to the other walls, but actually what I'm going to do is I'm going to use quite a fun command called the copy guided 3D command. I can choose my detail objects, and automatically I can fit, or I can choose where this curtain wall fits with respect to the context, the other entities around it. So like this, I can easily copy this window around, or this curtain wall around. Now this was still a very simple example. Let's look at a bit more complex geometry, like this lofted surface here. So this is a surface that was created using a simple loft between three guide curves. And And turning this into a window manually would be quite a lot of work, so that's why we can use the curtain wall command for this, which will make it a lot easier. So again, it asks me to select the face, and it will again create this first attempt at a grid based on some default parameters. Let's choose some panels of, let's say, 1.5 meters high and wide, like this. And it will approximate this lofted surface by this grid when choosing this option. Maybe let's make it a bit finer, 1200. There we go, to make it a bit smoother. When doing this, it asks you to planarize this face. It's actually a matter of approximation, because this face, well, we want to create planar grid cells, or the command will try to create planar grid cells. Otherwise you will have bended glass, which is not always ideal. In this case, we will choose not to planarize it. It depends on the type of surface, but sometimes it's just physically or mathematically not possible to planarize it. All right, we can still change some parameters. So by the way, you get this little needle view, which shows you the direction where the frame will actually be created. I can flip it around if I want to. So then it will be created outwards. Let's choose inwards here. And let's change some parameters like the width. Well, actually the width can stay. Let's change the depth to 150. And I can also choose my connection type. So basically, straight means the mullions and transoms will just come together in a sort of not in a solved way, so there will be gaps between the mullions and transoms at the corners. When I choose nodes, it will create an extra solid at each corner, trying to connect all of the mullions and transoms. And smooth means it will create some lofted surfaces to try and solve this these connections as well as possible. So let's try to choose smooth and see what the result is. So there we go. And I can see that it tries to solve these connections by lofting all of the mullions and transoms to this one point here. So yeah, play around a bit with that. Depending on the geometry, some things might not work out, and you need to play around a bit with the parameters to see what works best. But yeah, that gives you already a good idea of how to create windows and curtain walls on the fly using geometry in your model. Okay, let's take a look at another command to create geometry or components on the fly, and that's the BIMSTAIR command. So first of all, let me activate this section so I can look inside my building. And now I want to create a staircase going from the bottom floor to the first floor. If I want, I can manually create or model a staircase like this, but it's actually easier using the BIMSTAIR command, which already gives you a first pass at a possible design for a staircase. Okay, when I start the BIMSTAIR command, I can see that this special cursor appears at my cursor. It's a bit similar to the quick draw command, as in it snaps to existing geometry. So for example, I can see it snaps to these walls here. When I move my cursor around, it snaps to the actual floor slab as well. So depending on where my cursor is, I get different options. Okay, let's start creating this staircase from the first floor. I will snap to this wall and I will choose a distance, let's say 1800, and left click to start creating the staircase. Depending on where my cursor is, it will snap. So now it's snapping to the bottom floor, and it will give me some different options. So for example, I can choose to create a L-shaped staircase. by snapping to this wall here. Or if I move away, it will create a U-shaped type. And by hitting Control, I can choose between having just one landing in between the two flights, or I can have 3 flights like this. Also notice that it tries to snap to these configurations of the staircase. You can see sometimes my staircase will be like this, which is a bit more transparent. And sometimes it will be more like this, which is a darker blue. Actually, this darker blue means that it found the configuration of the staircase that exactly matches your requirements. So the requirements are actually stored inside the stair settings here, which contains information like the preferred riser height and so on. And so this ideal riser height is currently at 170 mil. And if it finds a configuration that hits this exact value of 170 mil, it will try to snap to it. If it doesn't find an exact configuration like this here, it will try to match this 170 mil as close as possible. Okay, so let me just left click and create this stair here. And you see as well automatically an opening is created based on the setting of stairs called the headroom. Okay, we can again actually use the propagate command to easily copy this staircase over to the rest of the building. And to do that, I will start propagate, choose my reference solids, which in this case are the floor slab and the 2 walls connecting. Choose my staircase as a detail object. It will create an abstraction of this detail or this situation, and we'll try to find similar locations where it can create the staircase, such as here, here, and here, and on the other side in this corner as well, which is a mirrored application. So I can choose to accept this, and now I have my staircase copied all over the building. You can still go and block edit this staircase as you see fit, so you can create some, you can change the thickness of the risers either by changing it in the parameters like this, or by actually going inside the block definition and making changes, changing the geometry to what your needs are. Okay, that's everything for this module on components. We will have a later chapter on components where we will show how to create components from scratch, how to make your own components. But for now, that's it for this module. So thanks for watching, and I'll see you in the next session.